Playing with the settings on my pressure switch on this pump, and I settled on 39 to 54. Basically what I did was I reduced the small screw until it has no pressure, because this actually changes your cut off pressure. So as you can see, I loosened it up so much that this screw is not putting any pressure on this plate. So really the only control here now is this major screw, which controls the cut in and cut out. So by doing that, I reduced it from a 20 psi split, where it would kick on at say 30 and kick off at 50, to a 15 psi split, which means the pump has to kick on more often, but it also means you spend less time at a low pressure. So now you can control the whole thing by the large screw, and I adjusted it till it was about kicking on at 39, kicking off at 54 for now, just kind of experimenting. Being at that higher level of pressure means you're going to have less overall capacity. If you have a 20-gallon tank, which is pretty standard, you're probably only going to get 5 gallons of capacity, assuming everything is working perfectly. But in this case, I have a couple extra tanks hooked up, so I have plenty of capacity to run at a higher pressure. And I have a reverse osmosis system, which operates a lot better at a higher pressure, so that's the goal. So anyways, now that I've adjusted my pressure upwards, I need to adjust the air pressure in my tanks. So in order to do that, I isolated all the water pressure from the house by shutting off these valves. And I'm going to drain the remaining pressure out of the system from this valve. And once that happens, once I reach the air pressure that's in my tanks, the water bladders inside the air tanks will collapse. Right now I'm at about 35 because this thing is off by 1 or 2 psi, this little gauge. And once I think my air pressure is set about 33, so I got to get about 3 more psi out of the system. To see the bladders collapse when it reaches that last little bit, and then it collapses suddenly. So now that the water pressure is out of the system, when you go to check the air pressure in the tank, you're going to get the actual air pressure. If you check this pressure before the water pressure is out of the system, all you're really looking at is your water pressure. And every tank can be slightly different, but if in case one has a leak, it'll show up now. And whatever tank has the lowest pressure will be the low pressure you saw before the bladder collapsed. So it raises the question of, why do I set my PSI at 2 psi below my cut on pressure of my pump? And the reason is because if you set the air pressure above the cut on of your pump, the water bladder will collapse before your pump kicks on. So that means you'll get like a sudden drop in water pressure while you're taking a shower, and then all of a sudden the pump will kick on and try to restore that pressure. So you want to set that below that level. And why wouldn't you want to set it way below that level? Because what ends up happening if you have your PSI too low, which in this case I do, at 33, I end up with a stretched bladder that doesn't get to use all of its capacity before the pump kicks back on. So theoretically it's bad for the bladder, for the water bladder, and also you're sabotaging your own capacity, because the pump kicks on before the air pressure in the tank has been able to push out all the water from the tank. So instead of getting 5, I probably have 5 gallons of capacity each tank, because I'm running at 39 psi on my cut-on pressure, and I'm not getting all that capacity. I'm probably only getting 3 or 4 gallons because it's not pushing the rest of that water out. So I'm going to use a portable battery-powered device to bring these each up to 37 psi. This is the Ryobi 18-volt inflator deflator. About 40 bucks at Home Depot. Very handy little tool. It's got a battery down in the center, and you can blow up basketballs, mattresses, tires, whatever. But for well tanks, it's been very useful. It's got a digital gauge on it, which you can't really see in this light. But as soon as you plug it on, you get to see your air pressure, which in this case is 33, which is a good thing because that's what it was when I set it about a month ago or so. And if you have an air leak, that number will decrease over time, which is a major pain in the butt. And if you can't stop the air leak by tightening up the flange bolts or if you have a hole that's rusted somewhere in the tank. Unfortunately, the tank is pretty much junk. I haven't had any success on fixing holes in steel tanks, really because they need to be fixed from the inside, patched from the inside. So basically what I'm going to do is I'm going to set my pressure here up to 37. Actually, I'm going to go to 38 just because you do lose a little bit of pressure when that cold water comes in, and because when I disconnect it, I'm probably going to lose a little pressure as well. So I set it for 38 and put it on automatic, and as soon as it reaches 38, it'll stop. Alright, that took about 2 minutes for this tank. I set it up a little higher. I wanted to make sure it actually gets to 38, and because actually when it shut off, it dropped back down to 37.5. So it depends on the size of the tank you're working with or the size of the tire you're working with. You're going to drop a little bit after it's turned off. It's not a big deal if you go a little too high on the pressure, because if you do get that sudden drop where it collapses the bladder before the pump kicks on, you can solve that by letting a little bit of air out of the tank. So you don't have to re-drain your system really or mess around too much to fix that problem. But if you go too low, basically you just won't know it. You'll just be missing some capacity. One thing to keep in mind is that if your water bladder collapses for any reason, like while you're doing this service, the water bladder collapses, it stirs up a lot of sediment. So if you have it set up where your pressure is too high and it collapses every time, it's going to stir up sediment almost every time. Eventually it'll clean itself up, but I gotta say, I've had well tanks that I've tried to clean by putting a little bit of water in and then letting it back out and putting it back in and letting some back out, and I did it over 100 times, and every single time it would have sediment coming back out at me. And it wasn't like a particularly nasty well, it's just that sediment builds up over time, and it doesn't take much like a fine clay sediment to create like a cloudy turbidity in your water. So if you do have it set up where the air pressure is too high relative to the pump and it's collapsing every time, it might stir up some turbidity into your water, and that could be a real pain in the butt for laundry, or depending on what kind of filtration system you have set up, it can clog up your filters. So you really want to keep that in mind, that there's going to be some sediment that's going to be kicked up in this process, and it's so you can kind of try to, maybe you can flush that out before you open up your main system. Both of those tanks are all set at 38.5, and now this is a newer tank from Gould's that's got the air pressure nozzle on the bottom, because I guess this tank is designed where it actually has the water bladder on the top and the air section on the bottom, and it's designed that way because it's got the pump sort of integrated with the tank, so the water sits on top, water sits in the bladder on top of the air pressure. That way it can tap in directly to that water from this little nipple here.